Hello everybody and welcome to today's video where I'm going to be showing you a little workaround that we can do to achieve a fixed time step using the Unity data-oriented technology stack. Now if you've been using Unity's DOTS or ECS, the entity component system, you may know that most of these systems operate with using an onUpdate function which executes the code every single frame. Now in game development, often we want to update things on a fixed time step because we can't be certain that our frame rate is going to be at a constant fixed rate throughout the duration of our game. Now, if you're familiar with traditional programming in Unity, there's something called the FixedUpdate method, and that will allow us to execute the code within that on a fixed time interval. Now, in DOTS, there's no equivalent to the FixedUpdate method quite yet. However, in the future, the simulation system group is going to update on a fixed time step by default. But in the meantime, we have to do a little bit of a workaround to achieve the same result. So that's what I'm going to be showing you how to do in today's video. Now, if you're interested in learning and developing in ECS, which you probably are if you're watching this video, I highly suggest that you go check out the Discord community that I'm building up right now. I'm trying to make that as a nice place where a bunch of ECS developers can go to ask questions and kind of share knowledge and help us all become more well-rounded developers. Also, if you found this video helpful, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos on Unity, DOTS, and ECS. Of course, if you have any questions for me or suggestions for future videos, feel free to leave those down in the comments section below. Now, one last thing before I jump into the actual project. This, by the way, is one of the ECS sample projects provided to us by Unity. Just kind of wanted to explain the theory of what we're actually going to be doing in today's video. So essentially the gist of it is we're going to go to the system that we want to update on a fixed time interval. And we're going to use an attribute which actually basically disables the onUpdate function so it doesn't actually execute every single frame. And then we're going to create a traditional MonoBehaviour with a FixedUpdate method. And within there, we're going to manually call the update method for our system. So that's basically how we can get it to update on a fixed time interval. And of course, just like normal FixedUpdate, we can manually set what the fixed time step will be. So we can choose if we want that to be a very rapid fixed time step or a more drawn out and delayed fixed time step. So anyways, let's jump into the video and I can show you how that all works. All right, so here we are in the fixed time step workaround scene under the advanced folder, which is part of these ECS samples. When you hit play, you can kind of see the effect that we're going for. Basically, we're spawning these waves from the different spawners. The one thing that I did change is I just went to the fixed time step slider and changed the maximum value from 1 to 0.1. And the reason I did that is just so the fixed time step variables are in a bit of a better range for us to work with. So now you'll take a look at what's going on here. At top we have the variable spawner, which is spawning one of these every single frame. And then if you look down at the fixed spawner, you'll see that it's running, it's spawning these on a fixed time interval. So if I actually hit pause here, you can see on the variable spawner, you'll notice that there's some larger gaps and some smaller gaps between all these different entities that we're spawning. And the reason for this is because the game isn't running at a fixed frame rate. It's kind of like a variable frame rate. It's pretty much always at the same kind of target frame rate, and that's why they're pretty evenly distributed, but you'll see every once in a while it takes a little bit longer or a little bit shorter to spawn one of these. Now, if you go down to the fixed spawner, you'll see that everything is evenly distributed across. And then if we continue the execution here, you'll see that we can kind of move this slider here. If we move it up, you'll see that as we increase the fixed time step, now it's going to decrease the rate of spawning. And then if we increase it all the way, you'll see that it vastly increases the number of these entities that we're spawning. So we can kind of play with these values and just kind of slowly separate these apart here. But again, if we hit pause, you'll see that they're still all very evenly distributed across. All right, so now just dive into the code real quickly here. So you'll see that this is in the move projectile system. And this is the system that actually moves the projectiles across the screen. You'll see that basically all it's doing is it's moving the translation component in the X direction every frame. And it's going to be doing that as long as the projectile should be alive in the game world. So if the alive time is above 5 seconds, then it's just going to go ahead and destroy that entity. So now if we take a look at the variable rate spawner system, you'll see that basically it's just an update function, and it goes through each of the variable spawner entities and just spawns a new entity every single frame. So you can can see here is where the entity is actually spawned, and then we're going to be setting some of the components for what the parent is, make the transform local to the parent. We'll actually set the translation, and so that's how we can kind of get that variable waving height. And then lastly, we'll just set the spawn time so it knows when to destroy itself. Now, if we take a look at the fixed rate spawner, it looks pretty much the same. We have basically the same onUpdate function here. Minor difference is that we're using the Unity engine time.time as opposed to in the variable rate spawner when we're using time.elapsed time. Just a slightly different method of keeping track of the elapsed time. And you'll see that it does actually have an onCreate function, but it works perfectly fine without this. So I'm not entirely sure why they put that in here, but the one important part is this attribute right here where it says disable auto creation. And what that means is it means that this onUpdate function is no longer going to be updated every single frame as it is in, say, the variable rate spawner system. And just a note with this disable auto creation, the onCreate function still does execute when we have this tag, but the disable auto creation means that this onUpdate function is not executed every single frame. So now how do we actually get this onUpdate function to execute? Well, we have to create a simple little MonoBehaviour, which is the fixed TimeStep updater. And again, you'll see a note at the top saying that this is just a temporary workaround. And again, the simulation system group will eventually use a fixed TimeStep by default. But basically what's happening here is we have a fixed rate spawner system variable, which we just call spawner system. And in the fixed update, we're first just going to check if it's equal to null. If it is, we'll set that equal to world.defaultGameObjectInjectionWorld.getterCreateSystem with the type of a fixed rate spawner system. And so that's basically how we can get access to the spawner system. And then basically all that we'll do at the end here is we'll just say spawner system.update. And again, this is in the fixed update. And so when we call this spawner system.update, then that's how we can actually manually call this onUpdate function. And then the other code in here is basically just using the slider value to actually set the time.fixedDelTime. And then we just set the slider label text to show the current value in milliseconds. So again, if we just go back to Unity, you can hit play here. And again, we can just play with this slider to increase the fixed time step as well as decrease that. All right, and so once again, that is the fixed time step workaround for Unity Dots. Of course, as you'll remember, Unity Dots doesn't have a fixed update equivalent right now, so we have to do this little bit of a workaround for now until in the future when the simulation system group is using a fixed time step by default. Anyways, if you enjoyed this video, I'd really appreciate it if you hit the like button. Also feel free to subscribe to the channel for lots more videos on Unity, Dots, and ECS. Of course, join our Discord community where if you have any questions or have any additional knowledge to share, that would be a really good place for that. But of course, you can leave any questions or suggestions for future videos down in the comment section right below this video. But anyways, I hope you all have a fantastic rest of your day, and I'll see you in the next one.